The interest equation. Getting it from nothing. Warning: the content of these slides may cause frustration, anger, or even rage. If you begin to experience any of these, it is recommended that you step away for a while until the feeling subsides. We are not responsible for damages done by a person made angry by this presentation, including, but not limited to, arson, treason, murder, other violence, destruction of property, trespassing, use of profanity, bullying, stealing, and other such criminal acts. If you happen to observe someone who is watching this presentation and is getting very angry, then run for your life. Warning: the device you are viewing this on is probably a choking hazard. Do not attempt to eat or feed someone else the device. It will be hard to chew and may cause choking. Do not allow small children or pets to use your device, as they will probably try to eat it. If you observe someone choking on your device, call 911 immediately. This presentation will teach you how to get the equation for calculating interest from nothing, lest you have forgotten it. Additionally, you will have a better understanding of the interest equation if you follow this presentation closely. As mentioned earlier, we have nothing to start with, therefore, let's make something up. Let's pretend that we just put $100 in a bank and the interest rate is 3%. With $100 in the bank and a 3% interest rate, there is $103 after 1 year, $106.09 after 2 years, $109.27 after 3 years. In order to find the equation, we need to take note of how many amounts in the previous slide were calculated. The following slide will show how these three numbers were calculated in terms of the $100 originally in the bank. First, let's establish what the variables are. M equals the amount of money put into the bank before any interest was applied to it. P equals the new amount of money in the account after interest was applied to it. N equals the number of times interest was compounded. In this presentation, we will assume it is compounded once a year. To calculate the balance after 1 year, the original amount was added to the original amount times the interest. Don't forget to convert the percent to a decimal before multiplying. The equation that shows this is typed below. To calculate the interest after 2 years, we take the amount in the bank after interest was applied once and add it to the amount after 1 year times the rate of interest. The equation that shows this is shown below. Notice how M has just been substituted by the equation on the previous slide. The equation that calculates the amount in the account after 3 years is just the first equation shown, with M being replaced by the equation on the last slide. As you can see, it is unlikely that someone will want to calculate interest this way, since it is long and tedious. Don't worry, the equation will be simplified. Here are the three equations we will use to find the interest equation. Here the equations have been slightly simplified. I has been multiplied through. Here, M has been factored out of all of the equations. When the unnecessary parentheses and ones are removed, we get the following. Here, like terms are added together. In order to simplify further, a pattern must be recognized. Pascal's triangle shows this pattern effectively. These numbers are the coefficients that go before constants or variables when a binomial is raised to a certain power. The top row represents the binomial being raised to 0. Every row you go down, the power increases by 1. For instance, the fourth row represents the coefficients resulting from a binomial being raised to the third power. In the next slide you will see how this applies to what we are doing. As you can see, the coefficients are in red. They look a lot like rows 2 through 4 of Pascal's triangle. This means we can simplify these down to a binomial raised to a power. The three equations have been simplified to M times a binomial. You should notice a pattern here with the powers. If the interest is compounded 1 time, the power is 1. If it has been compounded 2 times, the power is 2. This pattern continues, therefore, these three equations can be made into one. Here is the equation that was found after combining the three equations on the previous slide. It happens to be the equation for interest. Now one can find the amount of money in their account after 50 years with only this equation. As a reminder, P is the final amount in the account. M is the money initially deposited into the account. I is the rate of interest. N is the number of times interest has been compounded. Thank you for watching. We hope you enjoyed this video.